Alright guys, so I want to take a look at section 3.3. It starts on page 127, or at least the fun stuff starts on page 127. Look at the form, direction, and strength of scatter plots. And when we look at it, what can we notice about the dots, or what can we notice about the specific scenario that would kind of give us the dots in the certain shape that we see. So it looks something like this. They gave us two scatter plots. One of them has this shape going on. One has this shape going on. We should be able to see by now that this has a negative relationship going on. So as this number increases, remember there's numbers across the bottom here and numbers going up. So as these numbers increase, then these numbers decrease. So like when this number was very small, this number was really high. When this number got bigger, this number got smaller. In this one, it goes the other direction. As this number is small, this number is also small. As this number increases, this number is getting bigger and bigger and bigger. So kind of let's see what's going on. They ask us to kind of fit these two scatter plots into these two scenarios. So they're not necessarily on the correct side, as it is the way that they fit on the page for me right now. But so the first scenario was x. Remember the x value goes across the bottom here. So this is where x is, and this is where y is. So the typical like x-y axis. So x, the explanatory variable, they're saying is the city miles per gallon for a bunch of cars, and y, the response variable going up, is the highway miles per gallon of these 10 cars. So city miles per gallon and highway miles per gallon. That's the first scenario. The second scenario is let's put x and y over here, is that x is the sodium content of a bunch of cereals, and y is the Consumer Reports rating. Oh, I'm sorry, not cereals, peanut butters. I got stuck on the cereals from last time. And y is the Consumer Reports rating for those 10 peanut butters. So that's what we're looking at. So if we look at, if you think about just for a second, the city miles per gallon and then highway miles per gallon. Remember the city miles per gallon. Hopefully we know a little bit about cars to see what's going on here. City miles per gallon is how many miles you can drive on 1 gallon of gasoline in the city. Highway miles per gallon is how many miles you can drive on 1 gallon of gasoline on the highway. And those numbers are a little different, because in the city you're stop and go and all that kind of stuff, and highway you're kind of just going on cruise control for a while. Now, so what we're looking at is x is the city miles per gallon. So across the bottom here, this is supposed to be the city miles per gallon. Well, here or here, whether one of those two. And so we're saying, okay, as this number increases, what happens to the highway miles per gallon? As city miles per gallon increase, does that mean highway miles per gallon are going to decrease, or highway miles per gallon are going to increase? And so these guys got to think for a second. And what I come up with is, well, some cars have really good city miles per gallon, and they also have really good highway miles per gallon. I can't think of really any car that has really good city miles per gallon, but has really bad highway miles per gallon. That doesn't really make sense to me. That if I have really good city miles per gallon fuel economy, that on the highway I would have really bad fuel economy. So it seems to me that if I have a car that has really high city miles per gallon, it would also have really high highway miles per gallon. Also, if I had very low city miles per gallon, like some kind of a tank or a bus or something like that, would have very low city miles per gallon, it would probably also have very low highway miles per gallon. So as one increases, as the city miles per gallon increase, I would think that the highway miles per gallon would also increase. So A right here, the miles per gallon, I think would fit better with this scatter plot number 2. So we're going to say A right here. And hopefully that makes sense over here now. If you look at the sodium and the Consumer Reports rating, sodium for the most part is not good. It's good in certain amounts, but once we have too much sodium, I think things start getting unhealthy for us. And so I would think that if we had not that much sodium, we'd have a pretty high rating. We kind of already kind of understand how the Consumer Reports ratings go when we look at the cereals. A low amount of sodium would probably give us a higher rating. If we cram more and more and more and more sodium, which is in general a bad thing, into this peanut butter, then we would probably lower the rating because now it's not as good for us anymore. It's not you know, overall, if you had to rate this peanut butter on a scale of 1 to 100, if it has lots and lots of sodium in it, well, it probably isn't that good for you. So it probably doesn't have such high of a score. So I think this one also works. The more sodium we add to the peanut butter, the lower the rating gets. And that sort of works for me, I think, too. So I'm going to call this one B. And so that kind of logic is what we're going to use to kind of drive our thinking in the next for this section. So go ahead and give a try to number 2. There's three scatter plots and 3 scenarios that we have to match up, and come back and see me once we got that. Once we all kind of reach a consensus on that, and let's see where we end up. Good luck, guys.